This example says solve the inequality algebraically. This type of inequality is a rational inequality because I have a rational expression on this side. To solve the rational inequality, I need to first find the x-intercepts. We're going to find the x-intercepts by setting the numerator equal to 0 and solving. So I'll subtract 5 on both sides and get x equals -5. Then I'm going to find the undefined values for the expression, or the vertical asymptote, by setting the denominator equal to 0 and solving. So I'm adding 4 to both sides. That gives me x equals 4. These are the values that I'm going to put on my chart. Make sure you put them in order from smallest to largest. Then we're going to choose test points in each interval. So I need to pick a test point that's less than -5, like -6. I need to pick a test point in between -5 and 4, like 0. And I need to pick a test point that's greater than 4, like 5. And then we're going to take those test points, or x values, and we're going to substitute them into the rational expression x plus 5 over x minus 4. So our test points of -6, 0, and 4 will get substituted into the expression x plus 5 over x minus 4. And what we're looking for is to determine whether that rational expression comes out positive or negative in those intervals. So for the first test point, if we substitute it, we would get -6 plus 5 over -6 minus 4. -6 plus 5 is a negative, -6 minus 4 is a negative, and negative divided by a negative is a positive. So that first interval is a positive. Using the next test point, I'll substitute to get 0 plus 5 over 0 minus 4. 0 plus 5 is a positive, 0 minus 4 is a negative, a positive divided by a negative is a negative. So this next interval, the rational expression comes out negative in. Then our last test point of 4, I'll substitute that to get 4 plus 5 over, I substituted the wrong value. Okay, my test point is a 5, not a 4. So substituting my test point in of 5, I get 5 plus 5 over 5 minus 4. 5 plus 5 is a positive, 5 minus 4 is a positive, and a positive divided by a positive is a positive. So this last interval is a positive. The rational expression is a positive in that interval. Now then, going back to my original inequality, I was looking for that rational expression to be greater than 0. So I'm going to choose the intervals where my rational expression came out positive, which is greater than 0. So the interval notation for this first interval would be starting at -infinity and then going to that x-intercept of -5. I'm going to put a parenthesis on that -5 because I don't want to include it. I'm only looking for where the expression is greater than 0, and -5 is a value where the expression equals 0. Then the other interval we'll include in the solution set starts at 4 and goes to infinity. And we'll also put a parenthesis on that 4, but for another reason. 4 is where the vertical asymptote would be, and our rational expression is undefined at that value. So to solve the inequality, x plus 5 over x minus 4 is greater than 0, we have a solution set of -infinity to -5, union with 4 to infinity. Thank you for checking out my videos. Have a great day.